Hi guys, in today's video we will be going over Le Chatelier's principle and the concepts associated with it. Firstly, let's look at how this principle came to be. In 1888, Henry Le Chatelier suggested his fundamental principle of chemical equilibrium. He noticed that chemical systems react until they reach a state of equilibrium. He also observed that if chemicals in a state of equilibrium are disturbed in any way, they will react once more until equilibrium is reached, if this new equilibrium is achievable. Le Chatelier's principle states that whenever a system in equilibrium is disturbed by changes in chemical concentrations or physical conditions, the system will counter this with internal physical and chemical changes to re-establish a new equilibrium state if possible. Now, let's define even further. The new equilibrium will reduce the effects of the change added. However, the equilibrium constant will remain the same since the ratio of the concentrations of products to reactants will remain the same, just the concentrations will be in different quantities. The chemical changes to a system are the addition or removal of certain products or reactants. The physical changes include changes in temperature and changes in pressure due to a volume change. Now let's look at the effects of concentration on equilibrium. When the concentration of either a product or reactant is altered, the equilibrium will shift to decrease the concentration change. Thus, if the concentration of a reactant is increased, the equilibrium will shift in the direction of the reaction that uses the reactants, so that the reactant concentration decreases. The forward reaction is favored. There is a similar case when the concentration of the products is decreased, since the reaction will push forward in order to increase the concentration of the products, minimizing the effects of the stress added to the previous equilibrium. The equilibrium will shift right. Now, if we decrease the concentration of the reactants, then the reverse reaction will be favored since the equilibrium will shift in the direction of the reaction that produces the reactants, so that the reactant concentration increases. The equilibrium shifts left. The similar case is when we increase the concentration of the products. The reverse reaction will be favored and the equilibrium will shift left. Let's look at an example. Say we are given the reaction nitrogen gas plus hydrogen gas yields ammonia gas in a reversible reaction. Well, first let's see if the equation is balanced. As we look at the coefficients in front of the reactants and in front of the product, we can observe that the equation is indeed balanced. In addition, let's assume that this reaction is at equilibrium, which would mean that the forward and the reverse reactions are occurring at the same rate, aka the concentrations of the reactants and products will not change. Let's also assume that each of these circles here represents 1 mole of the gases, and let's assume that this is the ratio at equilibrium. Now, if we were to increase the concentration of the nitrogen gas, what would happen to equilibrium? Would it shift right or would it shift left? Well, according to Le Chatelier's principle, the reaction will be favored forward since the effects of adding N2 are lessened this way. Thus, the equilibrium will shift right, and the nitrogen gas and hydrogen gas will be used to create ammonia. Now, what would happen if we were to decrease the concentration of N2? Would the equilibrium shift right or would it shift left? Well, Le Chatelier's principle predicts that the equilibrium will shift to increase the concentration of the reactants in this case. So, the reverse reaction will be favored, and some ammonia will change back to nitrogen gas and hydrogen gas. The equilibrium shifts left. Now, this would mean that if we were to increase the concentration of the ammonia, then the reverse reaction would be favored, and the equilibrium would shift left. Now, this would be decreasing, and these guys would be increasing as the ammonia gas is used up. Okay, finally, how about if the ammonia concentration is decreased? Would the equilibrium shift right or would it shift left? Well, according to Le Chatelier's principle, it predicts that the equilibrium will shift to increase the concentration of the products in this case. So, some of the N2 and some of the H2 will be used up to produce more ammonia, and the equilibrium shifts right. Okay, so that was the effects of concentration change according to Le Chatelier's principle. We will look at the effects of temperature change on equilibrium now. Temperature is the only experimental variable that has any effect on the equilibrium constant. The direction that the equilibrium constant and equilibrium changes from temperature depends on if the reaction is endothermic or exothermic. Alright, so if the reaction is exothermic, it can be represented by reactants yields products plus heat. We must remember that heat is released during an exothermic reaction, and so it is a product of the reaction. Raising the temperature for an exothermic reaction is like increasing the concentration of the products. Increasing the temperature, which leads to an increase in heat, would thus shift the equilibrium left and move the reaction toward the reactant side. Okay, let's look at this image here that I have chosen because I think it can help us better understand this concept as we visualize it. If we look at the reaction at the top, we can visualize that it is an exothermic reaction, and so that is why the heat is on the product side. We see that if we increase the temperature for this reaction, the equilibrium shifts to the left and the reverse reaction is favored. Now if we look at the second reaction, which is also exothermic, if we decrease the temperature, what would happen to the equilibrium? Well, the equilibrium would shift to the right, and so thus the forward reaction would be favored. So now you may be wondering, what if the reaction is endothermic? Well, for an endothermic reaction, increasing the temperature is like increasing the concentration of the reactants, since an endothermic reaction can be seen as heat plus reactants yields products, which would mean that increasing the concentration of a reactant, which is actually increasing the temperature for an endothermic reaction, would move the equilibrium toward the product side, and the equilibrium constant would increase, since the constant is the concentration of products divided by the concentration of the reactants. Alright, let's look at an example for temperature. Say we have the reaction sulfur dioxide plus oxygen gas yields sulfur trioxide in a reversible reaction, and the reaction is exothermic. This means that heat will be on the product side. Now, what happens if we increase the heat? What will happen to equilibrium? Well, an increase in heat favors the endothermic reaction because it takes in energy, and the reverse reaction is endothermic, so the reverse reaction is favored. The yield of SO3 will decrease and the equilibrium will shift left. Okay, so what if the heat was decreased? What would happen to equilibrium? Well, a decrease in heat favors the exothermic reaction because it releases energy. The forward reaction is exothermic, so the forward reaction is favored, and the production of SO3 will increase. The equilibrium will shift right. Finally, let's look at the effects of pressure on equilibrium. First, we must acknowledge that if the pressure of a gaseous reaction mixture is changed, the equilibrium will shift to minimize that change. This means that if pressure increases, the equilibrium will move to decrease the pressure and vice versa. There are three ways to change the pressure of a constant temperature reaction system involving gaseous components. One is adding or removing a gaseous reactant or product. This changes the concentrations which we have previously discussed. Another way pressure is changed is by the addition of an inert gas to a constant volume reaction mixture. This will indeed increase the pressure in the system, but will have no effect on the equilibrium because an inert gas is not involved in the reaction. Finally, changing the volume of the system is our bingo here. When the volume is changed, the pressure changes, and so the concentrations of products and reactants will change in order to minimize the pressure change. Okay, moreover, we must realize that pressure is inversely related to volume. We can remember this by referencing to Boyle's law, P1V1 equals T2V2. This equation shows that an increase in pressure will result in a decrease in volume and vice versa. So when there is an increase in pressure, the equilibrium will shift towards the side of the reaction with fewer moles of gas. When there is a decrease in pressure, the equilibrium will shift towards the side of the reaction with more moles of gas. This all applies only to reactions involving gases. For our example, we will once more look at the reaction for ammonia. Looking at the coefficients before the reactants and before the product, we realize that the ratio is 4 molecules of reactant gas to 2 molecules of product gas. So, an increase in pressure will favor the reaction that decreases the number of gas molecules to lessen the effect of that increase in pressure. There are fewer molecules of gas in the products as compared to the reactants, so the equilibrium will shift to the right as the forward reaction is favored. Now, if there is a decrease in pressure, the reverse reaction would be favored because it would create more molecules of gas, lessening the effect of the decrease in pressure. The equilibrium would shift left. I hope this explanation helped you understand the concepts behind Le Chatelier's principle. Thanks for watching, and I appreciate any feedback. Have a wonderful day, and consider hitting that subscribe button.